How do we architects design? How do we create something new? At least partially, we do it by sampling our own knowledge and experience. It can come through our studies, looking at other buildings and designs, or even completely other domains like art. Generative AI can work similarly. We can train a model with loads of data and then use it to generate something new. In this particular project, it was mainly a question of how to communicate something as complicated as a building to a computer. We achieved it through graphs. Graphs can contain all information of a 3D model and more. It is a very flexible data format that is also machine readable. We created a dataset consisting of 4 modernist buildings, each parametrically augmented 100 times. Those 400 graphs were then used to train a graph-based autoencoder. An autoencoder is made up from 2 neural networks. The encoder is trained to reduce the information of the input as much as possible to a so-called latent vector. In our case, this vector has only 3 dimensions. The decoder then works as a mirror, trying to add as much information as possible to the 3 dimensions coming from the latent space. This model has 2 advantages. First, the bottleneck forces the model to compress its input to the most important and high-level features only. Second, we can detach the decoder and use it to generate new buildings from unknown latent vectors. Here you can see how the trained encoder maps the 400 buildings into the 3-dimensional latent space. You can also see how we can explore the neighborhood of the latent space to generate new buildings by inputting different coordinates into the decoder. We can also perform latent walks, giving us an even better view on how the model understands the dataset. Because we use graphs as a base, the conversion step to a 3D model plays a big role on the shape of the generated output, and it highlights perfectly the importance of the human designer in this application. Lastly, a physical prototype to navigate the latent space was developed to bring this application into the real world. This provides the most intuitive way to understand how the neural network works, and most importantly, it gives access to everybody. In architecture, most people don't have the background which enables them to understand our rather very technical papers, and therefore I find it very important to try finding new ways of sharing our research to colleagues. To sum up, the results are not perfect, but already show the potential of graph-based machine learning in architecture. The good thing is, this process is easily extendable by adding more data to the training of the model, enabling it to produce even better and more realistic results. Thanks a lot for listening.